The last thing I want to cover is how to get the information we want out of our calculator when dealing with inverse or arc functions. I'm going to start off with secant theta equals 4/3, and we're looking for an angle between 0 degrees and 180 degrees. If you look at our calculator over here, we don't have a secant button on there. What we realized earlier this semester was that secant theta is the reciprocal of cosine theta. That being the case, we can use the cosine function on our calculator. Looking at secant theta equals 4/3, well, if secant theta is 4/3, then that must mean that cosine theta is the reciprocal of 4/3. And to find the reciprocal of a fraction, we just flip it over. So cosine of theta is 3/4. Using our inverse functions, we know that that means that the arc cosine, or the inverse cosine of 3/4, will be the angle we're looking for. Now, a couple of things. The arc cosine gives us angles that are between 0 and 180 degrees, or 0 and pi if we're in radians, and that is what we were told to look for, so we're in good shape there. Our calculator is going to give us the right kind of number. So let's power on here, and the first thing I need to check, I noticed this in some of the quizzes I was reviewing. We all do it. We start working on our problem thinking our calculator's in radians when it's really in degrees, or the other way around. So I'm going to check my calculator. It looks like I am in degrees, or I'm in radians. I need degrees. So let's convert over that real quick. And now I need to know what the inverse cosine, so I'll hit secant cosine of 3/4 is, and I'll hit enter. So that means that tells me that theta is 41.41. Now, another thing I noticed with the first quiz is sometimes people would get something wrong because it would say to round to the nearest tenth or round to 1 decimal places, but then we'd use 2 or 3. Be careful about following the instructions. So I don't know what the instructions on this one say, so I'm going to leave it at 41.41 degrees. Let's look at the next one. Tangent of theta equals -3/5. If tangent of theta equals -3/5, then the relationship we're looking at would be that arctan of -3/5 would be our theta. Now again, arctan is the exact same thing as inverse tangent. I just like to flip back and forth to make sure you're comfortable with both forms, because you'll see them both ways in future calculus books and so forth. So looking at this, we're looking for an angle that's between -pi/2 and pi/2. And once again, going back to our inverse functions, tangent is between -pi/2 and pi/2, or -90 degrees and +90 degrees. So our calculator is going to give us exactly what we're looking for here. So I'm going to punch in, let's see, the other thing, we just changed from degrees to radians. So I need to go ahead and change my calculator back. So that is now back. We'll hit secant tangent to get to the inverse tangent. -3 divided by 5, close parentheses, hit enter, and this gives us a radian value. Theta is about -0.54 radians. Now that looks weird, but if we think about it, let's see, a full pi is 3.14, and the pi/2 is about 1.57. So -0.54 would be somewhere in this area. Maybe not quite that far down. But this is our answer. Theta is approximately -0.54 radians. Alright, the last one I want to look at is cosecant. Once again, there is no cosecant button on our calculator, so we need to rethink this. We need to think of it in terms of sines and cosines and tangents. So if cosecant of an angle is -7/4 and cosecant is the reciprocal of sine, then that would mean that sine of this angle is -4/7. Or, in other words, the inverse sine of -4/7 is our angle. So that's what we're looking for. Once again, we're in the correct zone. We're looking from -π/2 to +π/2. And that's what our calculator is going to give us when we ask for it. I've already got it in radians. I remember that, but it never hurts to look, double check. And I'm going to hit second sine -4/7, close parentheses, enter. And it looks like this angle is approximately -0.61 radians. Alright, you're ready to do this homework now.